Hi students, this is my attempt to help you with your journals. I've been hearing that journal questions are pretty rough this chapter, so here we go. Let's talk about journal questions for chapter 6. I'm going to give you hints and tips and things to think about. Let's start with the fact that if you're struggling to explain these or you feel like you're missing something, that's exactly why I give you these journals. Try not to get frustrated and use it as an opportunity to realize where your misconceptions are or where your lack of understanding is. And I'm more than happy to talk about these with you and answer any questions that you have. Okay, because I really do want you to understand them. This is not me trying to kill your grade, but to enhance your understanding and get you to the point of realizing what do I understand and what do I not understand. I'm just going to go through them one at a time. So question 1. Question 1, there's a lot to it. Here's my suggestion with question 1. It's often my suggestion with any question is start with a picture. If you can't tell what's going on, this is a very general question. Almost always this appears at some point in the free response question. Just one specific part of this question, but if we can conceptualize it, this is not something I'd memorize, but something that should make sense to you. So basically when we talk about curves, we have 4 different types of curves going back to chapter 5. We've got increasing curves that are concave up. We have increasing curves that are concave down. We have decreasing curves that are concave up. And we have decreasing curves that are concave down. And the combination of those are what makes my functions. So if we're looking at a specific function that's limited to strictly increasing, strictly decreasing, and or strictly concave up or down, what's happening to my area under my curve when I approximate it using one of my methods? Can I say for sure? And the answer to one or more of these might be, I don't know. There's no way to determine for sure. But if we start to draw things in, like if we start to draw in trapezoids, then we can see the trapezoid's hard to draw, but I can see that my trapezoid is a slightly over approximation in that case, and it's a slightly under approximation in this case. And then if I go with rectangles, then I could draw in rectangles. So I'm just going to start drawing left-hand rectangles. That means use the left-hand side of my rectangle, or the left-hand height for my rectangle. And I can start to draw in rectangles. And I'm only doing 2 of these pictures. I would say you need to do all 4 of the pictures and determine, is it the concavity that's changing my answer? As in, I've got concave up, and then I've got concave down, concave down. Is it that for both of my concave up, my answer is the same? Or does it have to do with the increasing, decreasing? Because obviously I have increasing, I can't spell, increasing, decreasing, and decreasing. So is it that my approximations are the same for the 2 increasing and the same for the 2 decreasing in terms of over and under? Or is it based on my concavity and these 2 are the same conclusion and these 2 are the same conclusion? I don't know if that helps, but that's how I would approach that problem. So I would draw some pictures and rough in some rectangles and see if you can figure out under, over, and what's happening. Moving on to question 2. So question 2, what does an integral represent? Wow, big concept. Question 2, I would go back to day 1 of 2nd semester, and I gave you a very basic scenario of I was taking a trip to Cincinnati, and we talked about, without using an integral notation, I've referred back to that several times, we were finding the integral. If you're struggling with question 2 because it's too vague and abstract, then I would swap that out or combine it with question 7, because question 7 gives you a little bit more concrete way to deal with it. But question 2, and really 7 you could make into this, I'm really looking for you to put a context with it. So context, a lot of times we talk about motion, velocity, acceleration, position. I don't know if that helps. We've also generalized that when we talk about integrals of rates of change, there's a way to summarize that. So in terms of motion, a lot of times we're talking about our velocity function inside the integral. Swap that out with any other rate of change. Look at your free response packet, and there'd be some good examples in there that you could generalize what's an integral telling me. Question 3. Question 3, I'm not sure how to, maybe we're overthinking question 3 because there's a lot of calculus going on. If you can just somewhat put into words for me, write out the theorem, the conclusion of the theorem, and then explain what's happening. What is your F? What is your capital F? What is happening? And I think that'll get you pretty far with question 3. Okay, that one might be worth Googling. I don't know if there's some good answers online. Maybe somebody has a great way of explaining it. That's not off limits. So if you want to see what's out there, see if you can find something. Question 4. Sorry about that. Question 4. So obviously there's a slight difference in those two integrals. And I'm sure if you stared at this one long enough, you figured out that the difference is that I have an x here and a t there. So try not to focus so much on the difference is x versus t. But the difference is that I have an x which is matching with my x there, and I have a t which is not matching with my x here. So my suggestion would be, and maybe we're bothered by the fact that I have what we consider indefinite integrals, and we haven't talked about those a whole lot. So if you're bothered by the fact that there is nothing here for my limits of integration, you can certainly put either numbers or variables there. And I would suggest that you actually, for this one, figure out what would be, maybe just try to find your antiderivative, evaluate what your integral would be, and see where that takes you, because you should not be getting the same answer, since essentially our function, I'm grouping these two as my function, my functions are different because of that t and x. And think about the difference, I guess, between a constant and a variable in your integrand. Because basically any letter can represent a variable or a constant. How do I know what it is? Question 5. Question 5 is a great question for you to consider. You might already know this because I think it came up at one point, but it's been a while. If you're struggling with question 5, I would actually pull an example. Like, just get an actual function that you're finding that you're evaluating using the fundamental theorem of calculus. And instead of just ignoring the plus c, when you do your antiderivative, actually put a plus c at the end. Then plug in your limits of integration and see what happens to that plus c when you evaluate it. So go off of any worksheets, any My Math Lab assignment where you were evaluating using the fundamental theorem of calculus and you already know the answer, and just try reworking it and put that plus c in. Okay, so I guess my suggestion is that can't be it for your example, for your answer for 5, because I am asking you to explain or tell me why. But do an example, and I think you'll get there. Question 6, explain why the statement is incorrect. So you should go back to, for this one, I would say your colored worksheets where we're dealing with, there was one that was specifically talking about the integral of velocity and what that tells you. And then there was one, and that was one page. There was a separate page that was talking about your position, and I believe that was worksheet I that we were doing. I think it was blue. We were doing towards the end of class, and some of us didn't get to. Okay, so I would go back to that. The other thing you could do is take the antiderivative here. Antiderivative of your velocity function is your position function. So if I evaluate the definite integral of velocity from a to b, I get s of b, position at b minus position at a. And when I'm asking for this question, why is it not giving you your final position? By that I mean position at some value b after some interval a to b. So s of b, consider your final position, and initial position doesn't have to be at 0. So consider s of a your initial position. Again, s is my position function. see if that works, to think about that. You could rearrange that so you're solved for your final position, because that's certainly appearing in my equation. And you could also think about that one. What does this represent? The integral velocity tells me what, and you could conceptualize how that number is going to get me my final position, even though it's not directly telling me my final position. I think that's the best I can do to help you with that one. Number 7, visual representation. So my best hint to you on that one is 3 is a function, not just a number. So remember, this is a function. Use your fundamental theorem of calculus is a good way to do this one. Find your antiderivative, but that's the evaluation part. If we look at that as a function, what does f of x equal 3 look like? And draw it out. Think about what the integral represents. And this is a good way, like I said, to connect what is an integral and how does my fundamental theorem of calculus part 1 help me evaluate what it is that the integral is and find the answer for what it is the integral is representing. Good time with number 2 there if you want to connect those two. Hopefully this helps. Let me know if you have other questions.